Today's demo we will try to implement a linked list, simple linked list first. Okay, so first of all we need to create a new solution. Okay, next. Okay, we are in the projects. If I can go into that particular apply data structures, and we are in the week 3. We are open, and then I give that particular project name. So what is the name of the project? We are talking about the linked list implementation. Okay, and I create that particular specific project. So we go into the design view so that I can see my project. Inside that particular project, I right click and I say that I want to add a new. What is the new? Can I add a new file? I want to add actually the new class. So it's a node class. I say that create. It create that particular node class for me. So here I can say that int data. I can also say that string name. In the default constructor, I'm saying that name is equal to nothing and data is equal to 0. This is our data part. But remember, we are talking about a linked list, so we also need a link part. That link part actually is a node class type variable. The same class node we're talking about. That will be the, we say the next, and then we need to initialize whenever we are creating that particular specific. This is our constructor, default constructor. Okay, in the default constructor, we are initializing that particular next is equal to null. Understand? So what I am saying that we have take two values, one is a string, one is a data, integer type, and then we have a link part which will contain the address of the next node in that particular linked list. And then we have that particular default constructor. We can also have another constructor which actually take two values as an integer, d and string name. I also need to make it a string as well to be simple. So that particular name is equal to and data is equal to d, and then we have the next is equal to null. So we will receive two values, we will assign those two values inside that new node that we have created, and the next part is null, which does not, it means that we don't have the link of the next element in that particular linked list yet. Okay, so that is our node part, node class. We can also, I think, create that the like we can generate those insert templates. No, okay. So we can simply say that. I think it's a command M. No. We need to have the getter and setter methods. Okay. So how we can get and set methods? We get and set We don't need to that particular specific out of the this one. Where either you declare something like this, in which automatically the Android, not Android, the C sharp will automatically take care, create those get and set methods for you, or you can do it by yourself, like int get data return data. I mean, you write it by yourself, or you can do it like that, whatever you are preferring. Look at that. Here we have int data get and set methods, node get and set methods. Okay, so it's totally up to you that how you are to implement that set and get methods. But this is our node class, in which we have two data parts, one next link, and then we have the constructors whenever we are creating those things. Now we need to create another class. I want to create another class that is actually, I right click on that, add a new thing, and then that will be our linked list. Linked list class. New, it has created that one. Here we are saying that we are creating a node first, or you can say head. And here in that particular default constructor, we are saying that first, I mean, we don't have any first node here, so we are saying that assign it to null. We can also have those set and get methods for that particular first node. Is it clear? Right? I mean, we are just saying that if we want to create a linked list, then we need to have that particular first node address, because after that every node has the list address or the reference of the next element. But first we have to keep up with us. If we lose the key first node address, it means we will lose the whole linked list. I mean, we don't know where to start, then how we can have it. Understand? So that's why we need to keep the address of the first node, so that we know that where we need to start, where that particular linked list is starting. Understand? And then we have that particular, what you can say, that create node. Maybe it will not return me anything. What's going on? We are saying that void create linked list, and when we are creating that particular linked list, we are giving them the value d, and because we have two data parts, so string n. Now we are creating. So what we need to do? Creating that particular linked list. It means we will create one node of our node class type. So we say that node n, or okay, I say new node is equal to new, not this one, new node, and we are giving d and n as a input. Remember what will happen? It will call actually this particular constructor for the node class, which take the two values as an input and assign those values, and the next part will be null when I am creating that particular node. And then we say that our first node is equal to new node. Why? Because this is the first node that we are creating in our linked list. So we want to keep that particular reference or the address inside our first variable, which is actually a node class type variable. Does it make sense? Whenever we are creating the linked list, we are creating one node only. And that address we are going to save inside our first. You call it a first, you call it a head, whatever you want to say. That is the first node inside the linked list. Is it clear? We are creating that particular method. Is it clear? So we have that particular linked list. Create a new linked list. So whenever you're creating a new linked list, we create a node, assign the data part, and the next part will be null. And we are going to save that particular node value inside our head node or the first node so that we can access that particular specifically linked list. Understand? That's very important to keep that particular first or head node value saved in our linked list class, the new data structure that we are defining, that we are constructing, that we are designing. Understand? So we are saying head node is equal to new head node, and again here we are testing. We can check as well that if that particular first node is not equal to null, then you assign that particular specific head node or not. So actually what we are trying to say, we are saying that boolean, it will return me, and then we can check if first is not equal to null, return true, else return false. Fine. I mean, we create that particular new node. Okay, well, that's not coming. Okay, fine. Oh, okay, that's not coming to your projectors. So what we are trying to do here, so I just added that particular specific if condition here. If the first is not equal to null, it means we are successfully created that particular node and assigned that value to the first. It means that then the first will not be null. If it is not null, return true, otherwise it will return false. So calling method, looking at that particular return type, it will know that the linked list has been created or not. Clear? How we can test that particular thing here? Simple. We can create a linked list object, list, and then we can say that if list dot, okay, we are trying to create a list, and then is equal to new linked list. And if we look at the default constructor, it say that first is equal to null. Understand? So we created that particular, I just try to remove that one the other way. So we have that created that particular linked list, and then we said list dot, why my create method is not coming, list dot, okay, we need to make it public because that's by default protected or private, so that's why it is not accessible outside. If you want to make it outside accessible, then we have to make it public so that we can access it. Now you can see that create list is coming, and again we need to give, like I said, that one value, and then I give my name as an input. So if that specific value return me the true, it means I will print something on the screen. We can simply say that linked list is created, and in the else part we can say that linked list is not created because it is returning me a false value, that specific create method. Is it fine? And here inside of saying that hello the world of linked list. So let's run this, only this particular part, how we can test it. Where's my, there's a build, 0 errors, fine. Yep, it's coming, I suppose. It is trying to work on that. Yep, look at that, linked list is created. Understand? And we can also make it something like that, this method more convenient. What does it mean? That we are saying that if first is double equal to null, then you need to create that particular specific part. Understand? In the else part, what we can say? Console dot write line, and we can simply say that that linked list is already created. Understand? Already created, and it will return false because it is already created, so we are not creating it again. Understand? Otherwise, every time you will run that particular specific program, every time it will create a new list with that particular specific thing. Of course, it will be, the other will be automatically removed from by the garbage collector, but that's not we want. That every time we start a run program, it will create that linked list from the scratch. No. Is it fine? Do you understand my point? So what we are saying that if that particular first is null, create a new node with the values which are coming inside, and then assign that value to the first and return true or false. And if that particular first is not null, I mean it is already created, already first is pointing to some particular specific node value, then you say that linked list is already created and return false. We can try to do something like this. I again call the same link create method, then this time it will say that linked list is not created. Reason is that it is already created, so we can't do anything. Of course, it will, in the meanwhile, it will also present that thing. Now, what other method we need to have in that particular data structure? Creation, okay, yes, we need to create. What else? Sorry? We need to add a node. Okay, so we must have a specific, what you can say that method or the create a node. So we go into our linked list and again create another method. Public, maybe it does not return me anything. Add node, and that particular add node will take two values, again int d and string n. Now again, maybe it is not necessary, maybe the user, instead of starting that create node, it directly call that particular add method without creating that particular linked list first. It just call that particular add node method. Then what we need to do in that particular specific situation when actually he has not called that create node method? I mean, we need to check first is null or not. Okay, if the first is double equal to null, then we do a different thing, and if the first is not null, then we do a different way. So when it is first is null, what we need to do? Again, we can simply call that particular create linked list method. Simply, because it is null, so we can say that create linked list and pass d and n. Simple. We have already done that. Why we need to do it again for the first node? It will go and check and everything it will return. If the first is double equal to null. If it is not, then what we need to do? Of course, we need to do a node is equal to new node, and then we need to give that particular d and n as an input to this one. It will create a node. Now the point is where we need to put that particular value. It is a second node, is a third node, is a fourth node, is a fifth node, we don't know. How many times that previously the user has called that add node method. Now we have different ways. We are adding that particular new node at the first node or at the last node. I mean, we are adding the what you want. You say first, I will add first. You say last, it should be added last. But we have different ways to do that. Do you understand my point? So I am adding that particular node, adding new node as a first node, and the first node will become the next of this one. Fine. So we have created that particular node, and then we say that first node this particular node dot set node dot next. Okay, let me make that public. If I'm making it a public, not this one. Okay, yeah, we have not set those method set and get methods here, so we need to provide those set and get methods here. Set and get. Okay, so we need to set that particular specific value. We say a node dot next is equal to node dot next. Node dot next equal to first. Simple. Node dot next. Why it is giving me this is inaccessible due to its protection level. Okay, we need to make it public, but what does it mean by public? If we make it public, then okay, so node dot next is equal to first. So this new node which we have created, its first next pointer is actually point to that particular first, and then we can simply say that first is equal to node. Now what is happening here? Linked list operation, create a new node, complexity analysis that we will talk about later. Okay, so what is happening here? So we have that particular first node. This is our first node, 34, with and head node or the first node is actually pointing to this particular one. We create a new node with some values and its next is null. Now we are saying that what we did in our program, that this particular node dot next is equal to first. What is first? This one. So it will create that particular link here. You understand? And then we are saying that the first is equal to this particular node. Yeah, that is what we are done. So once we are done, we are add a new node at the start of the linked list or as a first node. Is it clear? Again, this is our, this complexity that we'll talk about later. Right now we are just implementing and then we'll talk about the complexity. This first node, this is our list which is already exists. And then we call that particular add next or add node method. When you call that particular node add node method, it will create a new node. In our specific implementation, we have two parts. One is the integer and then is a string. Second one is a string. So it will actually, here we'll have two values instead of 24. We have a 24 plus some name. That will be a data part. But next pointer is null. Then after creating that particular node, what we are saying that node.next, it means we are pointing, we are asking about, we are telling about this particular next pointer, and then we are saying that node.next is equal to first. So whatever the value of the first is, that is this one, it will create that particular link here. Then we are remove that particular link and assign that first to this new node. And again we have our linked list, but we have added a new element at the beginning of that particular. Clear? So that is what we have done. Create a new node. This node.next is equal to first, and then first is equal to this node. Is it clear? Now we have said that we want to add an element at the beginning of that particular linked list. But what if we want to find out if we want to add a element at the end of that particular list? Make sense or no? Or is all confusing? Guys, adding at the start. Now we want to go and add at the last of that particular node. How we can do that? So first of all, I just say that I have a public void add last node method. Again, it will take two values as an integer, int d and string n. Okay, and then again I check. I just make it copy here, and then this particular part I need to change. The first part is again add last node. If the first is null, create that particular linked list. If it is not, then of course we need to create a node. We have created the node. Okay, fine. We have the address of only what? The first node. Yes or no? Which is here in this particular list, in this particular class. This first node, data part of this linked list class. We have the address of only the first. We don't have the address of the last node. Clear? Yes or no? So first of all, we need to move a pointer. We need to find out the reference of the last node. Is it fine? How we can do that? So we create a new node, that's fine. We have created that particular new node. Now we need to find out reference of the last node. We need to find out that particular specific reference. How we can do that? So we can say that we have a node n is equal to not a node n is equal to first, because this is we already have. And while n dot next is not equal to null. Remember, when we talk about a linked list, the last node next pointer is null. Yes or no? The last node does not point to anything else, so that next pointer will be null. And then we are saying that assign that node n is equal to first, and then sorry, we also have an n here, so we can't use that one. Current node, and simply we can say that current, or we can say that last node. Okay, last node is equal to first. We don't know, and because we have already checked that first is not equal to null or not. If it is not null, it means we are saying that last node is equal to first. And while the next of this current node or the last node is not equal to null, we are saying that last node is equal to last node dot next. We are moving that pointer to the next until and unless that next pointer become null. So our last node variable, this last node variable will point to the last node which exists in that particular linked list. Now what we need to do? First of all, that we need to say that particular, we need to fix those pointer, setting the next link of the last or the current last node. So last node dot next is equal to node. The new node, this is the new node created. So we are saying that the last node next pointer will point to this new node that we have created. Yes or no? So last node dot next is equal to node, and then we are done. That particular node has been added at the end of that particular linked list. Clear? Let me show you that particular specific. It will make, we have some animation. So this is adding the first. Okay. Forget about that complexity, we will talk about later. So now we have that particular list, and we want to add a element. This is more diverse. So actually what we have done, we assign a new node, a temporary or the last node pointer that we have just said, it will assign to the first. And then we say that while its next is not equal to null, it will start moving towards the next. Actually, this is a traversing, so it will also print that particular value. It will print the value, go to the next. In our case, we are not doing anything. We say that if that particular next pointer is not null, go to the next. Print it, check the next pointer is not equal to null, go to the next. Next pointer is not equal to null, go to the next. Next pointer is not equal to null, remain there. Now we have that particular last pointer, that temporary or the last node pointer is pointing at this particular node. Maybe I think we also have, yeah. So we have a last pointer here at the first node, and we check the next item is not null, go to the next. Next item is not null, go to the next, 54. Next item is not equal to null, go to the last. So our last pointer is actually here at 72. Then we create a new node. That last dot next will become this particular node. I mean, we are moving that one, we are moving, and here, and then we are creating that particular not null, from null value we are assigning this particular value. So it will point to this one, and once it is done, so this particular item is already added at the end of the list. Clear? And that is what exactly we are doing in our. Is it fine? So what we are doing, I mean, we can say that we move that particular specific, creating the new node afterwards. First of all, we assign the last node, that is a temp pointer, to the first one. And if the next item, if the next pointer is null, move it to the next, and when it's reached the end of the node, last node it has reached, then we say that create a new node and assign the last node dot next is equal to that particular new node, and that will add the items at the add last node. When you say add node, it will add automatically at the first, and then here you are saying that add last node. Clear? Is it fine? Adding or no? Is it?
I'm seeing, is it better to keep a variable for last node instead of going one by one?
Again, it's totally depend on the implementation details. You can say I have a first node, I have a last node. But what if you say that I want to insert something in between? How many pointers you are going to have it? Yes, it is possible that you will say that why not I have another, like here instead of having that particular node, I say that node and I also have a last. Okay, I also have that particular specific last. I make it a public so that I can access it, and then I can simply go here, and I don't need to do that particular part because we assign a pointer, assign a reference to the first node, and then move next, and I simply here I can simply say that last dot next is equal to node, and because new node has become the last, so I say that last is equal to node. Yes, it is possible. It is perfectly possible. It depends how you are implementing. It is perfectly possible. But for every time you are adding that particular add a node, create a node, then you also need to make sure that particular last pointer is assigned in appropriate way. Like here, in this case, we can simply say that last is equal to null. Before we can say that first is not equal to null, we say that last is equal to first, because they are, this is the first, this is the last, because we are creating that one. Okay. Okay, we need to add that particular specific. What's going on? Okay, fine. So we have this one, fine, and then we also need to add first node is done. But when we are adding the first node, last node, okay, fine. Last node will be remain there. We don't need to worry about it because we are adding at the first one. And then when we say add last, so we create a linked list. It is done. So in this case, we are saying that this thing. So it's totally depends on what you want to do. You want to keep 2 pointers in that particular linked list, first and last. Yes, you can do that. No problem. If you want not only want to keep the first one, then you have to go to the last and then you add. If we want to insert something, we want to insert a new node, linked list operation, insert after. These are different operations that we need to implement by ourselves. That's the only thing we are doing. Insert. So when we want to insert after, I want to insert something after 34 or 54, then what we need to do? First of all, we need to find out the pointer where you want to insert. Yes or no? So first of all, we need to move our temporary pointer or something like that to that specific node, after which we want to add the value. Create a new node. That new node dot next will become the this pointer dot next. Temp, that's new node 96 dot next becomes equal to the temp dot next. Now we say that temp dot next is equal to this new node, removing that pointer and assigning it to the this one. So now look at that. The link is created between all the elements. but we have inserted this element here in between, inserted that particular element here. Clear? So that is insert after. Okay, how we can you tell me? Again, first of all, we need to create that particular specific method, public void insert after, and it will take two values, int d comma string n. Same we can check if first is double equal to null, then we can simply say that create linked list. We can give d and n to that one. Fine. In the else part, now one more thing, we can say insert after. This is the values that we are giving to put into the node, but after which node we want to insert. So we need to give another node value here. Now, based on how you are identifying the node, maybe that name is repeating, but that integer value is unique for each and every one. I mean, again, it depends how uniquely you identify that particular specific node. So you need to give that particular values as well to identify that particular node after which we want to add. Understand? So what we can do? We can give an integer value and number. Now based on this particular number, we want to search that specific node inside that specific linked list. If it exists over there, then we add the node after it. Do you understand my point? So here we can simply say that a node, we are calling temp is equal to first, and then we are saying that while first dot, again we need to make that particular specific value public so that we can access it, public int. Okay, so dot data is not equal to num. Why? Here we don't use first, we use temp because this is a temporary variable that we are going to move forward. So we say temp dot data is not equal to number, and it is also possible that that particular specific element that we are searching, it does not exist actually inside the linked list. We also need to check that temp is not equal to null. If the temp is null, it means that we have gone through from the start to the end, and then we have not find that specific value inside that any node. Understand? So we say that temp is equal to temp dot next. So moving the pointer next, checking the data part and comparing with the number. If they are equal, it will stop. The temp will be at that point. If it is not the case and temp has become null, it means that we don't find any value. So if we check after this while loop, we check if temp is double equal to null, we can simply say that we cannot insert that particular specific node in the linked list as that node after which we need to add the data is not there. Do you understand my point? So we can simply say that console dot write line cannot insert not existed that specific node after which we want to check. Okay, this should be null value, not the num. And in the else part, the temp is not null. It means that we have found that particular specific value, and if we have found that particular value, then we need to add the node after that one. Okay, so again, node is equal to new node, and we give the d and n as a value. It will create a new node. Then what we need to say? We say that node.next is equal to temp.next. Confusing, all that next going on. And then we can simply say that temp.next is equal to node. Remember that if we don't put these steps in order, then maybe you will lose the link between the remaining part of that particular linked list. For example, if I say that I go back here into my slide, so we have a temporary pointer which is moving. It's come down here. Here we want to add. We create that particular node, but before we can create that particular link here, before we can create that link, we say that temp.next is equal to node. Temp.next equal to node. Before we can create that link, what will happen? That particular part of the linked list will be lost. Why? Because that next is actually null, and if we have not pointed it before we can break that link, then this particular part will automatically lost. We can't access that particular part. So that's why those steps are very important. First, we need to create that link with this one. This node dot next is equal to temp dot next, and then you say that temp dot next is equal to that particular node, and that is exactly, does it fine? First, node dot next is equal to temp dot next, and then temp dot next is equal to node. If you reverse the order of these two steps, then actually you will lose a part of your linked list, which is after that temp node where we are pointing. Understand? So that's very important. So insert after. What about if we want to insert before? These are, I mean, we are just talking about the insert part. We are not talking about the delete yet. Do you understand? I want to delete insert a node before a specific node. Now we say insert after. Now we want to add a. So we can simply say that public void insert before. Again, it will take two values, int d and string n. We can check if the first is double equal to null. We can simply say that create linked list and d comma n, we can give it to you, because that's the first item we want to insert. What after? There does not exist anything. So what before and what after doesn't matter. In the else part, if that linked list has some elements in it, then we need to first of all find out that particular pointer. Let me go back to my slides, and then we say that insert before. And when you say insert before, we need two pointers. Why? For example, I want to insert before 54. Why we need that previous pointer? For example, if we have only the temporary pointer temp, we create a node, we can't change the value because this is what we want. This 34 next go to 96 and 96 next go to 54. Yes, that is what we want to create those links. If our pointer is temp only and we don't have that previous one, what will happen? We don't have access to that particular specific node 34, and we can't change the 34 next go to 96. So we need a previous one. Now again, we can simply say that node.next is equal to temp and previous.next is equal to node. We will remove that connection, that 34 to 54, assign it to 96 and 96 to 54. So that's why we need a previous. We need a two pointers. One is before, one is on the current node that before which we want to add. Clear? Does it make sense? Or no? And this is how we can do that. We can simply say that temp is equal to head node or the first, previous is equal to head node or the first, and then we can simply say that while temp is not equal to null. Temp, this is temp. The temp is not equal to null if temp dot data is double equal to node break. If we have find that specific node before which we want to add the value, it will break. And then if it is not the case, then we can simply say that previous is equal to temp and temp is equal to the next node. Temp will go to the next node and the previous will come to the temp. In the beginning, they are both at the first. If temp is not double equal to null, it means that we want to add the last or add the first. I mean, there does not exist any. Temp is null. We are saying that if it is before that, we are adding the last value. Or we can simply say that we can't add, does not exist, just like we have done before. Again, depending on the implementation details, what you want to do. You don't find that specific node before which you want to add the value, then you can simply say the add at the length, add at the last. Or you can simply say that sorry, we can't add that particular value because that node before which you want us to add, it does not exist. In the else part, we have found that particular specific node, so we want to add. Create a new node. That node dot next become temp, and the previous dot next become new node. Clear? So we need two pointers. Node temp is equal to first, and previous is equal to first. While temp is not equal to null. Again, we need another value, just like our insert after insert before, we also need another value, that is number. That will help us to find out. We can simply say if temp dot data is double equal to number, we say that break. We break that particular loop. In the else part, we can simply say that temp is equal to temp dot next previous is equal to temp. First we say that previous is equal to temp, and then we say that temp is equal to temp dot next. Okay, first we say that the previous is equal to temp, and then we say that the temp will go to the next node or point to the next node. Understand? And then we can check if temp is double equal to null, it means we have reached the end of the list and we have not find that specific value. Now we can simply say that add last node, and what will be the node? It will be D and N as an input. That does not node that we are searching, it does not exist, so we are adding at the end of that particular one. So D and N, these are the values of that particular node that will go as an input to that one. And if the else part, we can simply say that node is equal to new node, and then we give the D and N value as an input, and then you say that node dot next is equal to temp, and then previous dot next is equal to node. Previous will point to the node, node next will point to the temp, and we have created their link. Done. Fine. I also want to create another method that is actually public method. It does not return me anything. Print linked list. It will print all the elements in that particular linked list. And then we say that node is equal to first, and then we say that while that particular node is not equal to null, what it will do, it will console dot write line, it will node dot data, and we will say that slash t, and then we say name, and we say plus node dot we also need to make this thing as a public as well. Node dot name. Okay, so we are printing the data part and the name part, and then we are simply say that node is equal to node dot next. So actually every time it will print the values in that particular node and go to the next node, go to the next node, go to the, that reference is moving forward, and it will go until that particular node become next, because last node has the next pointer null. So when this node become null, it means we have reached the end of the linked list. Or okay, so we have added after, added before, add node, add last, all those methods. So let's test it. We can simply say that list dot add. So we want to add 2, that will be added on the Kara head of the list. Then list dot add last. Who want to add 3, and who is that? Renzo. A few name I remember. Huh? And then we can not this one. List dot insert. I want to insert before Renzo. Okay, so when I before Renzo, first of all I need to give the value 4, and then the name Camacho. And what else? And then I need to give the value before the node, I want to add, and I know that Renzo exists in my node, so one pointer will be at the Kara and one pointer will be at the Renzo, and then the node Camacho will be added in between the Kara and Renzo. Yeah, and then I say that list dot insert after. We have used that before. Insert before, and now I want to add after. I want to add after Camacho. Again, it will be before the Renzo, but fine. So we say 5, and then I give the name. What else we have? Daniel. Daniel is gone. And then I want to add it after 4. And then at the end, I simply say that list dot print. I want to print that specific list. Cross our fingers, run that program. Is it working fine without any error? It looked like. Wow. Fine. our all the methods which we have implemented, they are working perfectly fine. Remember, we created with the Abbas, and then we say add Kara, and add mean it will add at the first. So it will remove the Abbas next, and Kara become the first node of that particular linked list. And then I add Camacho before the Renzo, so it is before. And then I add Daniel after Camacho, again it is that. So it is at the right place, and then at the end I am printing that particular specific complete linked list starting from the first to the last. It is printing. Does it fine? Does it make sense? Let me stop my video.